Space is an exciting frontier. The vast expanse of the universe holds countless mysteries and opportunities for exploration. From the moment humans first looked up at the stars, we've been captivated by the idea of venturing beyond our planet. The allure of space travel has driven us to develop incredible technologies and embark on daring missions. But as we reach further into the cosmos, we encounter unique challenges that must be addressed to ensure the safety and well-being of astronauts. One of the most significant challenges is the lack of gravity, also known as zero gravity. In the microgravity environment of space, the rules that govern our daily lives on Earth no longer apply. This can have profound effects on both the human body and the equipment we rely on for space missions. On Earth, gravity is a constant force that shapes our existence. It holds us down, gives us weight, and influences how we move and interact with our environment. Our bodies have evolved to function optimally under the influence of gravity. However, in space, without this familiar force, astronauts experience a completely different reality. They float effortlessly, and objects that would normally stay put drift around unpredictably. Gravity is something we often take for granted. It keeps our feet firmly planted on the ground and ensures that objects fall when dropped. This force is essential for many bodily functions, including maintaining bone density and muscle strength. Without gravity, our bodies begin to undergo changes that can be detrimental to our health. In the absence of gravity, muscles and bones no longer have to work as hard to support the body. This can lead to muscle atrophy and a decrease in bone density. Astronauts who spend extended periods in space must contend with these physical changes, which can have long-term health implications. Floating in zero gravity might sound like fun, but it presents numerous challenges. Simple tasks become more complicated, and the lack of resistance can make it difficult to perform everyday activities. Astronauts must adapt to this new environment and find ways to navigate and work effectively. The physical toll of zero gravity is significant. Muscles weaken, and bones lose density, increasing the risk of fractures and other injuries. To counteract these effects, astronauts must engage in rigorous exercise routines designed to mimic the resistance they would experience on Earth. Exercise is crucial for maintaining health in space. Astronauts spend several hours each day performing resistance exercises using specialized equipment to help maintain muscle mass and bone density. Despite these efforts, the effects of prolonged exposure to zero gravity can still be challenging to manage. The need for a solution to the problem of zero gravity is clear. As we plan for longer missions, such as trips to Mars or extended stays on the Moon, finding ways to mitigate the effects of microgravity becomes increasingly important. Researchers are exploring various methods to create artificial gravity environments that could help protect astronauts' health. One promising approach is the development of rotating space habitats. By creating a centrifugal force, these habitats could simulate the effects of gravity, providing a more Earth-like environment for astronauts. This concept has the potential to revolutionize long-duration space travel and make it safer for humans to explore the far reaches of our solar system. As we continue to push the boundaries of space exploration, addressing the problem of zero gravity is essential. With innovative solutions like artificial gravity, we can ensure that astronauts remain healthy and capable, paving the way for humanity's future among the stars. Artificial gravity is a force that mimics the effects of Earth's gravity. It isn't real gravity, but it acts like it. Imagine a giant spinning spaceship. The rotation creates a force that pushes objects outwards. This outward force feels like gravity. Artificial gravity would allow astronauts to live and work in space more comfortably. It would help them stay healthy and prevent the negative effects of zero gravity. Artificial gravity is crucial for long-term space travel. Imagine traveling to Mars or beyond. Such a journey would take months or even years. Without artificial gravity, astronauts would experience serious health problems. Their bones and muscles would weaken. They would be more susceptible to illness. Artificial gravity would make space travel safer and healthier. It would allow astronauts to live and work in space for extended periods. This is essential for future space exploration. Currently, there is no way to create artificial gravity like in science fiction. In movies and TV shows, we often see spaceships with artificial gravity, allowing astronauts to walk around as if they were on Earth. However, in reality, creating such an environment is a significant challenge. The absence of gravity in space leads to various health issues for astronauts, including muscle atrophy and bone density loss. Therefore, finding a way to simulate gravity is crucial for long-term space missions. However, scientists are exploring different methods. Researchers and engineers are tirelessly working on innovative solutions to this problem. They are conducting experiments, running simulations, and developing prototypes to understand how artificial gravity can be achieved. The goal is to create a sustainable environment for astronauts, especially for missions to Mars and beyond, where the journey could take months or even years. One method involves rotating a spacecraft. By spinning the spacecraft or a section of it, centrifugal force is generated. This force pushes objects and people towards the outer edge, simulating the effects of gravity. The concept is similar to how a spinning amusement park ride works, where riders are pushed against the walls of the ride. As mentioned earlier, rotation creates centrifugal force, which can mimic gravity. This method has been extensively studied and is considered one of the most promising approaches. However, there are challenges, such as ensuring the rotation speed is safe and comfortable for astronauts, and dealing with the Coriolis effect, which can cause disorientation and motion sickness. Another approach is to use linear acceleration. By constantly accelerating a spacecraft in a straight line, a force similar to gravity can be created. This method relies on the principle of inertia, where objects inside the spacecraft are pushed towards the rear, simulating the effects of gravity. By constantly accelerating a spacecraft, we could create a force similar to gravity. This approach is theoretically sound, but it requires a significant amount of energy and advanced propulsion systems. Additionally, maintaining a constant acceleration over long periods is a technical challenge that needs to be addressed. These methods are still in the early stages of development. While the concepts are promising, there is still a long way to go before they can be implemented in real space missions. Researchers are continuously testing and refining these ideas to overcome the technical and practical challenges. More research is needed to make them a reality. The journey to achieving artificial gravity is complex and requires collaboration across various scientific and engineering disciplines. With continued effort and innovation, we may one day see artificial gravity as a standard feature in spacecraft, making long-duration space travel safer and more comfortable for astronauts. Section 5: The Power of Centrifugal Force. Centrifugal force is a fascinating and essential concept in the realm of physics. It plays a crucial role in various applications, from amusement park rides to advanced space travel technologies. Centrifugal force is a key concept in artificial gravity. This force is not a fundamental force of nature but rather a result of inertia, the tendency of an object to resist changes in its state of motion. When an object moves in a circular path, it experiences an outward force due to its inertia. It's the force that pushes objects outwards when they rotate around a central point. Think of a merry-go-round. As the ride spins, the children on it feel as if they are being pushed outward, away from the center. This sensation is due to centrifugal force. As it spins, you feel a force pushing you outwards. This is centrifugal force. This force is directly proportional to the mass of the object and the square of its velocity, and inversely proportional to the radius of the circular path. The faster the spin, the stronger the force. In space, we could use centrifugal force to create artificial gravity. This concept is particularly important for long-duration space missions, where the absence of gravity can have detrimental effects on the human body, such as muscle atrophy and bone density loss. By rotating a spacecraft or a section of it, we could generate a force that feels like gravity. This artificial gravity could help astronauts maintain their physical health during extended periods in space. Engineers and scientists are actively researching and testing various designs to make this concept a reality, ensuring that future space travelers can live and work comfortably in a microgravity environment. The future of artificial gravity is full of possibilities. Imagine giant space stations with rotating sections, providing comfortable living and working spaces for astronauts. Picture spacecraft using advanced propulsion systems to accelerate and create artificial gravity during long journeys. Artificial gravity could revolutionize space travel. It could make it possible to establish permanent human settlements on the Moon, Mars, and beyond. Despite its potential, artificial gravity faces significant challenges. One challenge is the engineering needed to create and maintain spinning structures in space. Another challenge is the cost. Developing and deploying artificial gravity systems would require enormous resources. Overcoming these challenges will require advancements in materials, science, propulsion technology, and our understanding of physics. Artificial gravity might seem like science fiction, but it's a real scientific pursuit, The quest to create artificial gravity is driven by our desire to explore the cosmos and push the boundaries of human ingenuity. If we can overcome the challenges, artificial gravity could unlock a universe of possibilities. It could enable us to travel farther, explore more, and expand our presence in space. Artificial gravity is a crucial element in humanity's quest to explore the cosmos. It offers a solution to the challenges of long-duration space travel and opens up a realm of possibilities for our future in space. While challenges remain, the pursuit of artificial gravity exemplifies our relentless spirit of discovery and our determination to reach for the stars.